I have a question for you. How do you choose an airfoil for a wing? First option, you choose it among thousands of profiles into a library. Second option, you use maybe Profili, Xoptfoil2 and so on, Gemini, and then you are slightly modifying the profile, changing the thickness, the camber, the point of the camber, the point of the thickness. So you are slightly modifying it. Or you go into Xfoil and you use the full inverse or the mixed inverse method, which is really a daunting task, and this is an iterative process. It's really a PIA. But now I have another solution for you. It's a tool that is using the Xfoil core with the multi-threading process of your computer, and it's simply calculating thousands of shapes with the power of your computer and giving you a solution, a shape of what you want. So I'll come back a few seconds about the history of library. For example, in Profili, we can find tons of profiles and we can sort them by specifying some range thickness or range camber to help us to achieve our choice. It has never been so easy on internet to find out tons of profiles, for example, in this database of all tools, or in this site, the Airfoil Aerodynamic Group coordinated database with more than 1,600 profiles. So when we go to the next step here through Xoptfoil2, we could somehow modify through the scars, camber, and thickness menu, and here we can change the value and the position of the camber or of the thickness. Sometimes, depending on the application, you can make a mix between two profiles and give a specific percentage of the A profile into the B profile and reciprocally. When we go it, we are now stepping in the Xfoil inverse design method, and we have the mixed inverse and the full inverse design method. Whatever the method is, what is important to understand is that we start from the velocity distribution that is here in blue to define the airfoil shape. While before we were choosing directly the shape or we were modifying, now we work from this velocity distribution. So I don't want to enter in detail here, and I want you to understand that the mixed inverse design routine is more about altering, modifying an existing profile, fixing some problems, while the full inverse design routine is more about generating a new overall geometry. That's what I want you to remind, because it will be useful when we're gonna to talk about Xoptfoil, which is the topic of the video. Welcome in Xoptfoil2, which is the third generation of the Xoptfoil application. And this is an airfoil optimizer. It works more by designing some specific targets that you want in terms of drag, in terms of lift, in terms of max lift, or in terms of LD and so on. So don't get me wrong, it is still using under the bonnet the Xfoil modular application, but it is simply calculating a lot of velocity distribution. But this time, rather than you do this manually by yourself in Xfoil, it is using some artificial intelligence through the particle swarm optimization, which allow you to match thousands of distribution to achieve your targets and then to deliver you the shapes that match your targets. We're gonna to watch some example. You're gonna to write some script and the machine will try to achieve through the multi-threading process. So it's good to have many cores on your computer. So the application will try to reach the target that you have set up into the script And the beauty of this, for example, is that you can give some weight, which means that you can give some priority. Let's say that you want to have a max lift of 1, but that's not your main priority. Your main priority is to have the best LD. So you would say, I set up a priority of 1 for the LD and a priority of 2 for the lift. So now let's study directly an example, and we're gonna to use the Selig 7003, who had been world championship in F3B long time ago. I will show you right now the script, which is in ENP here. First, the denomination of the airfoil, the shape function. So you remember I told you there are two specific ways. First is simply to optimize airfoil, and the second one is to design the overall geometry. So we are in the first case, we just want to optimize thickness, the camber. So the operating condition, and because we are in the redesigning of an existing airfoil, we don't need a lot of operating condition. So first of all, we set up the Reynolds regime for those operating points. We have only 2 points. So here we are specifying the lift. The lift, now the condition is 0.2, and we want to minimize the drag. That is the target. So we can give different type of target, very interesting. So the second condition at a lift of 0.7 is to say you will keep the LD at this lift, and we're gonna to freeze this LD like it was in the original Selig 7003. So in the second try, we will try to find out and to improve the maximum LD with the new optimized profile in the second try. But now we just stay here to make this working. We let the thickness like it was, so we can specify a thickness or a camber that you want. If you need a profile at 10%, it will work at 10%. We're gonna to start the program. So of course there is no fancy interface here, and you use this bat file to start the application. And now we can see that the swarm particle optimization has started. So we have 30 members. I think it's a number of iteration. So it's working now with a 15 iteration, and it has already improved a few percent, 4%, 4.5. So I tried to find his way through the calculation. It will take, I think, 2 or 3 minutes maximum. So he has completed already. It was less than 1 minute. Now you have the results. The first operating point condition, the improvement is in order of 7%. He kept the glide exactly the same, and the thickness is still 8%. So what I propose is to go to Xfoil. So in Xfoil we have the actual SD 7003, and we're gonna to import the new optimized profile. Here it is, and just to ask the polar. So we have already the polar of the original Selig, and this one we need to calculate it by using the batch analyze. Here we are, is calculating the polars, and we just need to hide all polars and select the only one that we are interested in. So I will put a triangle symbol. That's it. And now we need to select this one. and we can see that the drag had been reduced in the 0.2 lift area at 400,000 Reynolds, while the LD had been kept the same. But now I propose to come back here on the script and to change some little parameters. First of all, I want to have more detail because I'm personally interested to watch what happened in this new version, what has changed compared to the Xoptfoil JX, which was the previous version. And now what we will do, we will ask him to find the best LD at 0.7, and we're gonna to remove this condition because we want to outbound the previous value of the Selig 7003. The thickness will be the same, so I just need to do something right now, which is to suppress this one, and here we go. So we have really more information. Now it's more detailed. I really love it. We have the number of points, what it did on the airfoil. So I put 161 points. So you need to know that he's capable to work with the Bezier curves with a maximum of 6-point control. I suppose that it has already been done. Yeah, so it seems to be that we have lost a little bit in the drag department at 0.2, but we have gained, and that's really massive, 33% of max LD. I'm really curious to watch the curve, the graph into Xfoil. I propose now to download this profile in Xfoil, but first of all, we need to change the name, so that will be the second version, and you have to change the name inside the .dat file, and you have to change the name here. That's good. Now we are ready to download this profile. Ask the polar. Here we go. And we can see that we have lost a little bit in this area between 0 and 0.13, but we have massively minimized the drag in this area. Let's watch what happened with the LD, and we have now a massive and very impressive increase in the max LD. But of course, you will tell me, Guy, we are unlikely to really benefit at 400,000 Reynolds in this area because the lift is generally at this number of Reynolds for most of our planes between 0 and 0.3. So I propose to have a look at, let's say, 70,000 Reynolds triangles, and here at 70,000 Reynolds circles, and to look at 70,000 for the original Selig airfoil. So we can see that we have an impressive increase at this number of Reynolds, which is likely to happen when you are massively pulling the stick. You're gonna to have a really better lift here. I think that's quite explanatory. Let's come back to the documentation of Xoptfoil about the objective. You have two types of objective. You have the optimization objective. So you want minimum drag for a specific value of lift. You want the max LD. You want the minimum sink. You want a max lift. Or you want to have the best transition as possible for a specific lift. The second type of objective is when you give a value, numerical value. You want to achieve a specific value of drag, or you give specific value for target glide. So what I propose now is to start another example and to work on the synergy 94, and we will try to minimize the sink. So first of all, we need to put this guy into Xfoil. Here it is. We probably need to modify the number of points. No, it looks good. Okay, we will trust it. And now just calculating the polar. So why I'm asking the polar right now? Of course, this profile had been designed to work at a specific range of Reynolds. It's not difficult to guess that it is optimized for 95,000 Reynolds. So I want to know where is the minimum sink. We need to look at 90,000, 100,000 dollars. We reach this at alpha around 6. At alpha around 6, we have something like 0.91 coefficient of lift. Now we can modify here, and we're gonna to ask minimum sink. We want to keep the max glide. So the max glide, we need to come back here to watch the max glide. We got a max glide around 0.82. So we are good to go. Oh, the thickness, my God. I don't know what is thickness actually. We need to come back on the airfoil design. This is this thickness, 782. So we translate this in the script. We are good to go, but of course, the Reynolds is not the good one. Better to target this one. Okay, let's retry some results. So that was brutal, really impressive. We have improved the minimum sink of 73% for the lift that you have chosen, 0.91. The LD has improved of 53% for a targeted lift of 0.81. Okay, let's go to Xfoil5 to watch all of this. So I have already entered the new profile optimized here. This is the one with the triangle in green and the original synergy in violet. So let's have a look on the minimum sink, and really it's really impressive. If we gonna to have a look on the max LD, it's also really impressive. Of course, what you can think, it comes with some trade-off. I mean, it's likely that if we go faster, let's show some polars at 200,000 Reynolds, just to compare. We clearly see that when we are pushing the stick of the elevator under 0.5, we are having a lot of drag, which means that this profile is now very lifty. But I mean, Probably this profile right now is for very light, not windy conditions, and it could be fine for you. Just an example to show you how it works. The results are exactly the one expected and asked in the script. So I encourage you to read this documentation about Xoptfoil2. It's well done and you will learn a lot of things. The most important when you start to write your script is to strictly write the good syntax, and you have to look through the chapter what is the right syntax. I would say that the previous version documentation, Xoptfoil JX, was better. Just my opinion. I encourage you to print the documentation. In the previous version, I think that we have a more comprehensive reading about what we have to do. So optimization option generally in the beginning of the script. And after you start the chapter about the operating condition, what I want to emphasize is about that you find again many functions coming from Xfoil. So if you know Xfoil, you will be not lost. We go to another chapter, which is the geometry target, the constraint. So you have the curvature, initialization, about the polar generation. So it can generate some polar. I don't use it personally, and so on and so on. Xfoil paneling option, which is Xfoil stuff. And that's quite interesting because you can choose the encrypt, you can choose the trip on the extrado or on the intrado. So I cannot guarantee you that the syntax of the previous generation is working. Don't hesitate to drop some commentary and to start to dig in this application, because I think that it's very, very useful nowadays with all the capabilities we have.